You are watching channel Number Collage. Through this channel, we make sincere efforts to make you understand and like mathematics in a simple and easy manner. We need your cooperation in this regard. In this video, we will understand about arithmetic progression. The literal meaning of arithmetic progression would be to study the progress of a series of numbers when fixed numbers are added or subtracted arithmetically. To understand the meaning of arithmetic progression, we will consider few list of numbers. The first list is 2, 6, 10, 14, so and so forth. In this series of numbers, each number can be obtained by adding a fixed number to its previous number. For example, 10 can be obtained by adding a fixed number 4 to its previous number, which is 6. So 6 plus 4 will be 10. 14 can be obtained by adding 4 to its previous term 10. So 10 plus 4 will be 14. 6 can be obtained by adding 4 to its previous term 2. So 2 plus 4 will be 6. Consider another series 100, 70, 40, 10, so and so forth. Here also, each of these numbers, except the first one of course, can be obtained by adding a fixed number to its previous number. For example, 40 can be obtained by adding a fixed number minus 30 to its previous number, which is 70. So 70 minus 30 will be 40. 10 can be obtained by adding 40 with minus 30. So 40 minus 30 will be 10. 70 can be obtained by adding minus 30 to 100. So 100 minus 30 will be 70. Consider the third series minus 37, minus 33, minus 29, so and so forth. Here also, each of these terms can be obtained by adding a fixed number to its previous number. For example, minus 29 can be obtained by adding a fixed number 4 to its previous number, which is minus 33. So minus 33 plus 4 will be minus 29. Minus 33 can be obtained by adding minus 37 with 4. So minus 37 plus 4 will be minus 33. Fourth series of numbers is 1 divided by 15, 1 divided by 12, 1 divided by 10, so and so forth. In this series of numbers also, each number can be obtained by adding a fixed number to its previous number. For example, 1 divided by 10 can be obtained by adding a fixed number 1 divided by 60 to its previous number. So 1 divided by 12 plus 1 divided by 60 will be 1 divided by 10. Similarly, 1 divided by 12 also can be obtained by adding 1 divided by 60 to 1 divided by 15. So 1 divided by 15 plus 1 divided by 60 will be 1 divided by 12. All this can be done except with the first term. All such list of numbers where each number except the first one in the list can be obtained by adding a fixed number to its previous number is known as arithmetic progression, AP. Here, the fixed number is known as the common difference denoted by small d. Each number is called a term and the first term is denoted by small a. The most general form of arithmetic progression is a plus d, a plus 2d, a plus 3d, a plus 4d, so and so forth. Let us solve a few examples. For the arithmetic progression AP, 3 divided by 2, 1 divided by 2, minus 1 divided by 2, minus 3 divided by 2, so and so forth. Write the first term A and the common difference D. Here, the first term obviously is 3 divided by 2, so we write first term A equals 3 divided by 2. For finding the common difference, we will subtract 3 divided by 2 from 1 divided by 2, which will give us minus 1. Also, D is minus 1 divided by 2 minus 1 divided by 2, which will also be minus 1. Also, D equals minus 3 divided by 2 minus 1 divided by 2. Here minus of minus will become plus 1 divided by 2, and this 1 divided by 2 minus 3 divided by 2 gives us minus 1. Here we observe that the common difference is same everywhere, which also means that the given list of number is an AP. Write first 4 terms of the AP, where first term A and the common difference D is given. In the first example, the first term A is 4 and the common difference D is minus 3. We have the general form of AP as A plus D, A plus 2D, A plus 3D, A plus 4D, so and so forth. Here, the first term obviously will be A1, which is A, and it is given to be 4 here. The second term, A2, will be A plus D, where A is 4 and D is minus 3. So 4 minus 3 will be 1. The third term, A3, is A plus 2D, where A is 4 and D is minus 3. So 2 3s are minus 6 plus 4 will be minus 2. The fourth term will be A4, which will be A plus 3D, where A is 4 and D is minus 3. So 3 3s will be minus 9 plus 4, it will be minus 5. So the first 4 terms of the AP 4, 1, minus 2, minus 5. Next example for the following AP. Find the first term A and the common difference D. First example is minus 5, minus 1, 3, 7, so and so forth. Here the first term A is minus 5 and the common difference D equals minus 1 minus of minus 5. So it will be Minus of minus 5 will be 5. Minus 1, it will be 4. So the common difference D is 4. The second example, the AP is 0.6, 1.7, 2.8, 3.9, so and so forth. Here the first term obviously is A, which is 0.6, and the common difference D is 1.7 minus 0.6, which will be 1.1. So the first term is 0.6 and the common difference D is 1.1. In the next example, we are given a list of numbers and we have to find out whether that list of number is an AP or not. If it is an AP, then we have to find out the common difference D and we have to write 3 more terms. In the first example, the list is 2, 5 divided by 2, 3, 7 divided by 2, so and so forth. We do not know whether this list of number is an AP or not. We will check it out first. For that, we have to find the common difference. In order to find the common difference, we will use these terms. So, we will use our first common difference by using the first and the second term. So, we have D equals 5 divided by 2 minus 2, which will be 5 minus 2 multiplied by 2 will be minus 4. So 5 minus 4 is 1 divided by 2. For the second common difference, we will use the second and the third term, and we will use 3 minus 5 divided by 2. So it will be 3 2s are 6 minus 5, which will be 1 divided by 2. Again, D will be the fourth term minus its previous term, that is 3. So 7 divided by 2 minus 3. This will give us 7 minus 3 2s are 6. So it will be 7 minus 6, that is 1 divided by 2. We observe that in each of these cases, the common difference D works out to be a constant number. Therefore, we conclude that the given list of numbers is an AP. We are asked to find out 3 more terms of this AP. So, we can obtain the next 3 terms by adding the common difference 1 divided by 2 to its previous term. For example, to find the term next to 7 divided by 2, we will add 1 divided by 2 to 7 divided by 2. It will give us 8 divided by 2, which will be 4. So, the term next to 7 divided by 2 will be 4. So, in this manner, we will find 3 more terms as 4. Then after that, we will get 9 divided by 2, and next to that we will get 5. So 4, 9 divided by 2 and 5 are the 3 more terms which we have found. The next list of numbers is 3, 3 plus root 2, 3 plus 2 root 2, 3 plus 3 root 2, so and so forth. Here, for finding the common difference, we will use 3 pairs of successive terms. First, we will use D equals 3 plus root 2 minus its previous term, which is 3. 3 minus 3 will be 0, and we are left with root 2. So D is root 2. Now we will use the third term and the second term. So we have d equals 3 plus 2 root 2 minus 3 plus root 2. So here 3 minus 3 will be 0, 2 root 2 minus root 2 will be root 2. So we have d equals root 2. Now we will use the fourth term and the third term to find d. So we have d equals 3 plus 3 root 2 minus 3 plus 2 root 2. So here 3 minus 3 will become 0. 3 root 2 minus 2 root 2 will give us root 2. So in this case also d is root 2. So we observe that in each of these cases the common difference d works out to be a constant number which is root 2. Therefore, we conclude that the given list of numbers is an AP. In order to find next three terms, we have to add root 2, that is the common difference, to each of its previous number. So to find the fifth term, we have to add root 2 to this 3 plus 3 root 2. So it will give us 3 root 2 plus root 2 will be 4 root 2. So our fifth term will be 3 plus 4 root 2. Fifth term after adding root 2 will become 3 plus 5 root 2, and the next term will be 3 plus 6 root 2. So these are our next three terms of this AP. The next list of number is minus half, minus half, minus half, minus half, so and so forth. In this case, the common difference d is minus half minus of minus half, which will be minus of minus half will be plus half minus this half. So it will be half minus half 0, which is a fixed number. So since the common difference is a fixed number, we conclude that this list of number is an AP. The next three terms will also be minus half each. For example, in this list of number we are given a squared, a cube, a to the power 4, a to the power 5, so and so forth. In this case, the common difference d is, by using the second and the first term, will be a squared minus its previous term a. If we take a as the common factor, then we get a multiplied by a minus 1. So that is our first common difference. Again, by using the second and the third term, we get d equals a cube minus a squared. After taking a squared as the common factor, we get a squared times a minus 1. Now we will use fourth term and the third term to find the common difference. It gives us a to the power 4 minus a cube. After taking a cube as the common factor, we get a cube multiplied by a minus 1. We observe that a times a minus 1, a squared times a minus 1, a cube times a minus 1, all these numbers are different numbers, and in this case we do not get the common difference as a fixed number. Therefore, we conclude that this is not an AP. since this is not an AP, there is no question of finding 3 more terms. Next list of number is root 2, root 8, root 18, root 32, so on and so forth. First we will find the common difference by using the second and the first term. So we get D equals root 8 minus its previous term root 2. It will be root 8 is root 4 multiplied by 2, which will be square root of 4 is 2. So this will be 2 root 2 minus root 2. It will give us root 2. Now we will use the third and the second term to find D. So D will be root 18 minus root 8. Now root 18 can be written as root 9 multiplied by 2, and root 8 can be written as root 4 multiplied by 2. Now square root of 9 will be 3, square root of 4 will be 2, so we get 3 root 2 minus 2 root 2. 3 root 2 minus 2 root 2 will be root 2. Now we will use the fourth term and the third term to find the common difference D. So we have root 32 minus root 18. Root 32 can be written as root 16 multiplied by 2. Root 18 can be written as root 9 multiplied by 2. Root of 16 will be 4. Root of 9 will be 3. So we get 4 root 2 minus 3 root 2. And 4 root 2 minus 3 root 2 will be root 2. So we observe that the common difference in each of these cases is fixed, which is root 2. So we can conclude that this list of number is an AP. The next three numbers can be obtained by adding the common difference root 2 to its previous term. So the fifth term can be obtained by adding root 2 to root 32, but root 32 is 4 root 2. So 4 root 2 plus root 2 will give us 5 root 2. Next term to 5 root 2 can be obtained by adding root 2 to 5 root 2, which will give us 6 root 2, and next to that 7 root 2, so and so forth. So these are the three next terms of the given AP. Next list of number is 1 squared, 3 squared, 5 squared, 7 squared, so and so forth. That is 1 squared is 1, 3 squared is 9, 5 squared is 25, 7 squared is 49, so and so forth. Here we will find the common difference D first by using 9 and 1. So 9 minus 1 will be 8. After that D by using 25 and 9. 25 minus 9 is 16. Next by using 49 and 25. 49 minus 25 is 24. Here we observe that the common difference is in each case different. 8, 16, 24, which is not constant. Since common difference is not a constant number, it implies that the given series of numbers is not an AP. The next series of numbers is 1 squared, 5 squared, 7 squared, and 73. That is 1 squared is 1, 5 squared is 25, 7 squared is 49, and 73 is 73. So here the common difference first by using 25 and minus is 25 minus 1, that is 24. Next, by using 49 and 25, 49 minus 25 is 24. Next, by using 73 and 49, 73 minus 49 is 24. Here we observe that the common difference d in each of these cases is the same. Since the common difference is a constant number, it implies that the given list of numbers is an AP. So this is about the arithmetic progression, its meaning, the first term, the common difference, and what makes a series of numbers an arithmetic progression AP. In the next video, we will understand about the nth term of an AP. Hope you liked this video. If you did, please click like and most importantly, subscribe this channel. Thanks for watching. Have a nice day.